I'm Anil Kumar, and here is a thinking application question on derivatives of functions. The question here is, the position of an object moving on a line at time t seconds is given by s of t equals to t cubed times t minus 1 whole square. Determine when the object changes direction. I'd like you to pause the video, copy the question, answer, and then look into my suggestion. This is indeed a very interesting question, and here students can actually make a mistake. So let us try to understand how to solve such a question. Let me begin by analyzing the given function, which is displacement function. So I'll sketch a graph, small graph here, which will help you to understand what we're trying to do. S of t, let's say S of t, is t cubed times t minus 1 whole square. In polynomials, we know how to sketch this. We have two zeros. One is at 0, the other one is at plus 1. Now, plus 1 is here. So the plus 1, 0 is quadratic in nature. This one is cubic in nature, right? And since the leading coefficient is positive, right side is up, right? So we have a graph where this 0 is cubic in nature, so this should be like this. And that is quadratic in nature, so it will be kind of like this. So that is the kind of graph which we have, right? So let me just join these points and complete this graph, and it could be kind of like this. So this is the kind of function which we have for displacement. Now, when we say determine when the object changes direction, that means there is a turning point. So changing direction means turning point, right? So changes direction. So changes direction means turning point on this displacement graph. Here you can see there is a 0 here, but it does not change its direction. Changing direction is these 2 points, as you can very clearly see. One of them is known to us, which is at t equals to 1, right? This point is at 0, and this is the one which we need to find, correct? At 0, we do see that the tangent is horizontal, but the direction does not change. So that is the key thing which you need to understand, okay? Now, another thing which you need to understand is that when the direction is changed, then the velocity becomes from sign of velocity changes, right? So changing direction means a turning point, and also change in sign of velocity. So if we say velocity is positive while going in the right direction, it is negative when going left. So if the tangent to the displacement, which is velocity, changes from positive to negative or negative to positive, then also the direction changes. So that is the concept. I hope now the concept is clear. You can still pause the video and answer the question. Well, let us begin to answer this question. So we have S of t as equals to t cubed times t minus 1 whole square. Now velocity with respect to time would be derivative of displacement, right? So we'll find derivative of this using product rule. So product of the first function, 3t square, times the second function, which is t minus 2, plus t cubed times product of the second, which is 2 times t minus 1. Now to solve the good practice is factor as much as you can. So we can factor out t square, and we can also factor t minus 1, right? So what do we get? We get 3t, and here we have taken t minus 1, so we get 3 times t minus 1. That is what we get from here, and on this side we get 2t, so we say plus 2t, right? So we have taken t square t minus 1, okay? So we have t square t minus 1. Let's open this and simplify. So we get 3t minus 3 plus 2t. That gives us t squared times t minus 1. 3t plus 2t is 5t minus 3. Now at the turning point, we know velocity is 0. So at turning point, let's say turning point, we know velocity v of t should be equal to 0. So this velocity will equate to 0. Let's equate this to 0 and find the value of t. So if we equate this to 0, we get three values of t. One is t equals to 0, the other one is t equals to 1, and then we have t equals to 3 over 5. So these are the three different times when the velocity is 0. So when the velocity becomes 0, there is a possibility of turning, right? There is a possibility of turning. So we should analyze the situation. What happens to this graph? Does it really change the direction or the value of the velocity when we are close to these points? Now clearly, since this particular factor is a square, so if you are close to 0, means left or right side of 0, the direction will not change for velocity, right? If you are on plus or minus side of these two factors, since they are linear factors, the direction will change, right? So what I will do here is, instead of calculating, we can actually sketch this graph, right? So let us sketch the velocity graph now. So the velocity graph has got three zeros, one at 0, one at 1, and at 3 over 5, which is 0.6, right? 0.6. So we are looking at three different zeros now. One is at 0. We are discussing velocity graph now. The other one is at 0.6, and let us say one we have here at 1. So these are the three zeros for velocity. So 0, 0.6, and at 1. So clearly this particular is at order 4, right side is up. We have to cross the line at these points. However, here we'll kind of go like this, right? So the function will be, the graph will be kind of like this. So that is how the function is going to be. I'm not calculating the velocity values, but I'm just giving positive and negative directions to you, right? So if I extend to this side, it has to be like this. You will see that the graph does not really go to the negative side. Since the velocity remains positive around 0, it is not changing direction. Do you get the idea? So what we are saying here is direction does not change. But in these 2 points, direction changes. Do you see that? Right? So here it is positive on both sides, but in this particular case, direction changes because the velocity becomes from positive to negative, and then here also from negative to positive, the direction changes. Do you see that? And therefore, the answer for this question is that the object changes direction at t equals to 0.6 seconds and 1 second, not at 0. That is kind of very important to understand from the given situation. So you do find turning points by equating velocity to 0, but then you have to check on either side of velocity whether it changes sign or not. If it does not change the sign, then the direction does not change, right? Which we saw from here also. Displacement graph, it kind of tangent is horizontal, however, the body keeps on moving in the forward direction. At this point, which corresponds to time equals to 0.6 seconds, the body changes direction. The object moves backwards, right? Or towards the left side if we are saying right is positive. Do you get the point? So here it returns back to the starting point and then move forward ahead, right? So that is key issue to understand from this video. I hope you appreciate it. Thank you and all the best.